Let's start. Hey everyone, welcome in. I'm Min from the KGC community team and really glad to have you all here today. Really appreciate your all time. This is our fourth speaker AMA, how we picked our topic from a little semantics to just enough ontology. We're here with Jim, Hendler, and Deborah. I think you all know these amazing people from this KG community, and Larry here is volunteered to moderate today. So thank you all for the speakers and moderator to join us. Before we really go into the AMA right away, we'd love to walk through what kind of community we are trying to build here. So KGC community is a amazing knowledge graphs practitioners community. We have more than 3,500 Slack members. If you have not joined our Slack, please join. And we have now more than actually 10,000 followers over on LinkedIn, X, and we'd love to have you more follow us on LinkedIn. And because we want to now really make our community bigger, we started this amazing AMA sessions monthly and demo days, and more coming. So please stay tuned. And the most important part of community, in person. So please don't forget to RSVP for our upcoming amazing KGC 2026 in-person conference that's gonna be on May 4th to 8th in Cornell Tech NYC. Would love to see you all in person and say hi to each other. And these amazing speakers will be there also. So yeah, definitely sign up today. And what we're building here in the KGC community is real casual technical questions regarding anything that's related to KG, share production use cases, discover new KG tools and research, and connect, with other practitioners and exactly like this kind of speakers we have today. Larry will now take it from here, but please, guys, feel free to drop questions in the chat, and me and Larry will try to bump that up during our session. All right.
Yeah, thanks so much. I'm really excited to welcome everybody here. This is a rare opportunity to get Jim and Deb together. They're actually sitting right in between their respective offices at RPI, so we're not too disruptive of their day, I'm glad to say. But they're both professors at RPI, really well known there and extremely well known in the semantic tech world. Jim probably best known as one of the co-authors of the Semantic Web article in Scientific American 25 years ago, almost to the day that appeared. Yeah, checking your time. And Deb, of course, is probably, I don't know, the world's leading ontologist. Is that a safe way to characterize you?
I'm certainly a contender, if not
if
not the
a
winner.
contender. Yeah, could have been, not could have been. You are a contender. Yeah. So welcome. I'll let each of you talk a little bit more about what you're up to these days and introduce yourselves.
Sure. I'm Deborah McGuinness, currently professor at RPI, Rensselaer Polytechnic Institute, previously running the Knowledge Systems Lab at Stanford and AI research at Bell Labs. And these days, I call myself Dr. Hybrid, Dr. Context, and I used to call myself Dr. Explanation, but I still call myself that. So, basically, I'm using AI to make a difference in the world, and I'm spending a lot of time trying to get that funded. So anybody who can help me, seriously welcome your help.
Yes.
Excellent. Thanks, Deb. Jim.
Me too. No. Well, so I'm actually, so I started out in AI literally 50 years ago, mostly in the cognitive AI area. And then that area sort of has always been around, but it's been eclipsed a lot. And now it's starting to come back a little bit as we look at some of the philosophical questions about LLMs, some of the practical questions. And then I also do technology policy. So I'm involved in the ACM's Tech Policy Council. I'm a member of the National Academy of Public Administration, where I'm involved in what they call their technology leadership group, which, again, a lot of these days, a lot of what we talk about is AI. So really, it's kind of all things AI and trying to figure out how we bring some of the semantic stuff back into the game.
Nice.
That makes me think of something that I started in AI because I took I was a quadruple major. Psychology, computer science, math, and physics. And I took this psychology class about how people think. And I'm like, oh, and then I took this AI class literally in the late 70s as an undergrad, but it was only a graduate class. And it was all about how to model how people thought and represented. And I'm still doing that decades later and still love that.
And again, ditto. I started 2 years earlier, but other than that, it's the same. Yeah.
That's so, one of the things I love about knowledge representation is that it's the most human thing in these computer systems, and that's kind of where it starts with that. Well, hey, I'm going to open it. I want to open it up as quickly as possible to questions, and I'll ask folks to drop their questions in the chat. And we'll queue you up if you want to elaborate on your questions. You'll have a chance, so feel free to drop an abbreviated version in the chat. But I want to start by asking, the title of your talk at KGC is From a Little Semantics to Just Enough Ontology. And I'll start with you, Jim, because the first part of that is your catchphrase, or I don't know if you call it a catchphrase, but you're well known for the saying, a little semantics goes a long way. Can you talk a little bit about the origins of that and what you mean by that?
Yeah. So, the origins of that actually go back to, um, oh gosh, I guess about um, early 90s. My research group was looking at bringing things to the web. How do we bring more not, we were looking at scalable knowledge rep. We needed to find a bunch of information somewhere that we could build a big knowledge base, knowledge graph, whatever you want to call it from. And the web was coming along. We said, oh, look, everything out there on the web, like all the computer science departments, there's one page which links to them. And then they all have a faculty page, and the faculty page lists interest. Let's just go grab that. So one of my students started to write what would have been a web crawler, came back to me and said, this would be so much easier if people would just put something around their faculty that says faculty. And we started thinking about this right as Google search was coming along and things like that, saying, search is getting harder because of ambiguity. And just simply being able to know that when somebody's saying Gates, are they talking about Bill Gates? Are they talking about Gates McFadden? Are they talking about the things you put in your garden? So that's what we were working on. We created a language called the Simple HTML Ontology Extensions, SHU, which we still claim is the first KR for the web. I went to DARPA. I showed SHU to a few people. They got excited about it. I was allowed to start a program. I brought Deb in almost immediately. Tim Berners-Lee joined. A number of the people actually who are sort of now the old timers in the KGC were there. And the slogan on our t-shirts was a little semantics goes a long way. So it had the SHU logo and a little pointer. And the idea being that in a very, very broad world of the web, trying to, really do deep semantics like expert systems and things like that wasn't going to work, but a little bit would make it much better. And then, of course, how to do that and things is what grew into the languages, the DARPA language. DARPA joined with Europe, so we had DAML plus OIL, and that became OWL. And, rest is history. And somewhere along the line, since I started working with Tim, we started writing the message. Tim and I were both friendly with Aura Lasala, and and I had both been doing a lot of agents research, and Tim and I were doing data research, and Aura and I were doing like data. And so it just made a perfect triangle, and that's what became the article.
That's fantastic. I love that confluence of folks. Yeah, and and I hope that inspires some questions from people. I just remind folks to drop their questions in the chat. But Deb, can you talk a little bit about Just Enough Ontology?
Sure. So I started my career, well, first in home information systems, so the home of the future at Bell Labs. And we were doing small amounts of essentially markup. But then I quickly transferred into applied AI and then fundamental AI research, where I was doing description logic. So very formal knowledge representation that was computable and very well defended by theory. And actually, we were developing the languages. So classic for classification of individuals and concepts. And we were funded by Bell Labs, and so we wanted to deploy it someplace, and we deployed it in these giant configuration systems. And the modeling was pretty sophisticated. And so that's where I kind of got my start. And actually, for the description logic people, I was very scruffy. And for the rest of the world, I was very formal. So I kind of played this intermediate level. And then I went to Stanford and co-ran and later ran the Knowledge Systems Lab. But at the time that I did that in the late 90s, it's harder now, but it was hard then to live in Silicon Valley on a Stanford salary. So the way you survive is you consult. So I was consulting a lot, and ontologies were a good thing then. Ontologies have been good and bad, and now they're good again. But I was doing a ton of consulting to people who thought they needed an ontology. And then I found out, what they really needed was kind of a taxonomy. And then I started to look at all these things that were kind of like ontologies on the web, like the Yahoo hierarchy claimed that it was using subclass of when it wasn't really. And so I started to see how portions of semantic representation could be incredibly valuable. And sometimes, too much would be hard to explain and hard to adopt. And then I got to AAAI in 1999, invited to be on a panel of ontologies. Are they just expert systems all over again? And before we did that panel, the night before, for 3 hours, we got together with like a little bit of alcohol, a little bit of food. 5 of us ontology experts said, well, what are we going to call an ontology? And then we came up with this spectrum from simple, just controlled vocabularies all the way up to subclasses, like informal subclasses, like what Yahoo had all over the place, to formal representations where you could count on reasoning, to very complicated things. And then I wrote this paper, Ontologies Come of Age, where I took every point on the spectrum and said, just this simple expressive level could be useful here, and this slightly more expressive level could be useful there. And I found places where you could have big financial impact, big impact in general at every level of the representational power. And so I started really looking at what portions of ontological representation or what portion of semantics really would make a difference in different contexts. And I found that just enough ontology for your context really made a big difference.
So this reminds me, just so people know how long Deborah and I have known each other. So Deborah went out when she was at Bell Labs with a request for people who were doing things with terminological logics on the web.
Which is what we called description logics at the time.
And she only got one response.
No, I got a couple.
A couple. Well, one local response, I guess, whatever. So I got invited down to Bell Labs. And oh God, that was before you even were at Stanford. So this must have been
it was
early 80s.
The first person in the AI principles research group, because we hired Ron Brockman to come in, but he wasn't there yet. So I was in that group and I was doing this survey and Jim came back to me basically with SHU. And I'm like, this is only kind of a terminological logic. I mean, it's like little bits of ontology. It's like just enough ontology. And he was the best response that I got, despite the fact that the description logic community or the terminological logic community was actually prolific, but very academic and very theoretical.
Right.
Nice. Yeah, I love that we have sorry, go ahead, Jim.
I was just saying, we've worked together one way or the other ever since. So I was at University of Maryland for my early career, 2007. I get asked to come to RPI and create a group that really would look into this stuff, data and knowledge on the web. And I was given a couple hires, and you can guess who was the first person I thought of.
I just love that we have, until we started preparing for this conversation, I didn't realize that we had that whole bottom up, all the data concerns, and then the top-down ontological, which is sort of like the conception of an ontology building, and you're sitting there right next to each other. That's no wonder you've been so productive and influential.
Yeah, well, and actually we decided to do this talk because Jim really did come from the bottom up, and maybe not so debatably. I kind of came from the top down, but my theoretician friends would say, well, you didn't really come from the top, but I came from the top from
High
a
enough.
perspective, yeah, high enough. And it's all about meeting in the middle in ways that the use cases require, the ways that you can make a difference, the way that your funder is happy that you're producing something that they can find of value. And this is the place where Jim and I are in basically violent agreement.
Nice. Hey, we've got a couple of questions in the queue. Let's get to those because this is an AMA, so let's get going with that. Paula asks, I'm finding that LLMs are finally bridging the gap between ontologies and business applications. What are your experiences on the interactions of ontologies and LLMs? Where do you see this going?
Yeah, super duper great question, Paula, and I hope you're coming to KGC and we can chat at length because I could write books on this. And by the way, Lisa Kendall and I wrote this book on ontology engineering before LLMs were like particularly useful and out there. And we're doing an update to the book because it's naive. It's not intelligent to not look at where LLMs can provide value if you're going to build an ontology. And of course, before you build an ontology, make sure that you understand what what you need to do with that ontology, and make sure that you've looked around like a lot to see what your starting points are. But looking around to find out what your starting points are, LLMs are amazingly good. Coming up, actually, geez, 2 years ago at the International Semantic Web Conference, I think there were three-ish papers on coming up with competency questions using LLMs, and they were doing a pretty decent job. And that was the one in Athens. So, a couple of years ago, I haven't like pounded on this lately, but what we're doing is looking at every step. So our book basically gives you a step-by-step process for kind of building ontologies. And really at every step, there's a place that you can use LLMs, but don't count on them without doing your checking and without like really dotting your I's and crossing your T's.
And the other thing I would throw in just real quick is, nowadays a lot of people are talking about a semantic layer that has to live between your data and the outside world. And really, if you revisit what Deb and I have been doing forever, it's bringing together data from diverse sources, creating that semantic layer so that you can get into that in some more careful way. And, that could be through language, but it separates the data from the LLM in a way that the LLM can't do by itself, especially, your corporate database may have a field called C12 colon 25X. That's not really helpful. And so when you can say that maps to these concepts in this way, and that maps to these other and really that's what the semantic web was born from. So it just fits together really nicely, coming data up, terms down, and meeting at the use cases. What do you need to do with this?
Yeah, and I might expand on this. So the semantic layer, we think that this is an opportunity for us. So business people with, important big projects to do, hopefully with big budgets to support them, are starting to talk a lot about a semantic layer. So I crashed the Gartner Analytics conference in Orlando in March. Crashed because I didn't pay the $5,000 to go into the exhibit hall, but I walked the halls and asked questions. Like everybody was talking about the semantic layer. And I'm like, what do you mean by that? And they didn't really have good definitions, but it's us. It's our field. This is our time.
Hey, one quick thing about that, and I'd love to get each of you's take on this. Like, there's an existing term, and we're so good at this, is our job to disambiguate these things. There's the term semantic layer exists in the business intelligence world as like a different thing, like more like database mappings, like business glossaries and stuff, kind of a simpler version. Is there a quick way, because I think there's a lot of people on this call who may need to be helping their colleagues at work or their enterprise leaders understand that difference. Do either of you have a take on that?
And to say this real quickly, it's kind of making that stuff machine readable. If you're using LLM technology, but you have a lot of technical terms, or you want to, you're one investment company, and there's plenty of other ones out there, and you want the LLM to know what you're good at, especially if people are asking questions looking for an advisor or something, then you really want it to do more than just generically know sort of across the board what the terms are that you're sharing, but really how those relate to the outside world.
Yeah, and so we at RPI in my group, we did the semantic data dictionary approach that took a data dictionary with some background semantics to map the data dictionary and the column headers to the terms in the ontology. I think that you can get more and more expressive and more granular as you need to, but that kind of the precise definitions that are good enough to map from the dirty data or the existing data into a vocabulary that's computationally useful, and if you need it to be computationally tractable too.
Got it. Thanks. Thanks. Well, so here's the next question in our chat. What surprises you most about the progress made in this domain, both from the high side and from what we have not yet figured out?
I think the strangest thing to me, and it's kind of weird, was somewhere around 2017, 2018, I was at one of the bigger AI conferences, which weren't quite as big as they are now. Some of us in the language community were talking about if only we had been playing around with recursive neural networks, meet language, and said, if only somebody would give us $10 billion in the world's biggest machine, just think what we could do. And we all laughed and went home, right? And a year later, ChatGPT comes along, having had $10 billion in the world's biggest computers. But, so that's sort of in some ways the fast answer was the surprise was how quickly that came up. And that investment being there was sort of surprising. The other thing I think is how excited people are about something that it does so poorly in some ways. So in other words, its generality is incredible. Its specificity starts to get weaker and weaker. And, I mentioned philosophy, I won't tell the story. I gave a whole talk to a philosophy colloquium called Can ChatGPT Tell a Lie? And the answer is it depends on your definition of lie, not on what ChatGPT does, right? I have a lot of examples, which I use in my classes of, here's something no human would ever do, right? Who was your third grade teacher? I didn't have one. Tell me about her. She was blah, 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 right? I mean, it doesn't make sense. So again, these things look great because we think of language as so tied to intelligence. But when you start getting into deeper and deeper levels of what you need at your corporation to do your science, whatever, that's where it hits.
Yeah, so the first thing that hit me was speed also, because in 1989, I was using a Boltzmann simulator, basically a neural network, to do conceptual retrieval and publish a paper at an information retrieval conference. But it ran for a weekend on a $100,000 symbolics machine. So the speed is amazing. But the other thing that really struck me is how much of a difference it can give you as a starting point. So I just consistently am shocked by how much of a jump start it gives me, no matter what I'm doing, whether I'm creating graphics, and by the way, I'm a bad graphics designer, creating graphics for a talk. I mean, usually I get screen grabs from my people, but sometimes I have to create it myself, and it does a good enough job that I don't have to refine it. So it often gives me that starting point and gives other people as well.
Nice.
And the one last thing I'd say on the surprise side of that, Larry, is again that I'm really surprised how average people playing with it are able to be told this is, quote, general intelligence and believe it.
Yeah.
And we won't go into that in too much detail unless someone else asks a question about it. But
I could share, there's been a bunch of papers lately about the epistemological fault lines between human and computer intelligence and about thinking fast, slow, and artificial and cognitive surrender. There's so much. We're starting to understand this thing that we all feel, I think, is coming out. And if folks are curious, ping me on LinkedIn. I can share those papers. But let's move to the next question. Pallavi asks, would like to know how knowledge representation needs to evolve for assisting LLMs better, which is quite different from being used for machine reasoning on understanding. Yeah, this different role. What do you think?
Yeah. So, I mean, I think there's opportunities for whole new language paradigms. So we can't only care about completeness. We can't only care about complexity. We can't only use the metrics that we've been using for years. I mean, again, Latvizada, who sadly is dead now, but he was on my committee, my master's committee, a gazillion years ago. But, fuzziness is back. And probabilistic reasoning is needed. So this whole kind of squishy closeness is something that we need to be able to model and work with. I was about to say reason, but make conclusions from, but keep track of where the limitations are, and where the don't count on this if you're doing it for this reason.
Yeah, I would say real quick, the primary paradigm that's developing in the world of using AI, no matter what you're using it for, is becoming iterative, right? So, prompt engineering, ask a bunch of different questions so you get it where you want. Human in the loop. And I think to get that human in the loop, the human knowledge, quote unquote, helps. And that's really where I see what we're doing can help the LLMs because can give it that more specific knowledge that's needed to start answering those harder questions.
Yeah, let me follow up on that one a little bit because that iterative nature and what you just said about getting, like, the whole point of knowledge representation is to get tacit human knowledge into systems, but then you're learning as you go. Are you aware of any architectures or methodologies? How would you might work with these iterative prompts that people are doing and learn from them how to capture that better? Deb, you're smiling.
Well, I'm smiling because one of the things that surprises me, I am a pretty good prompt engineer. I'm not great. But I usually, with 2 rounds of prompt engineering, I get a very good response. But like with 4 or 5 rounds of prompt engineering, it gets much worse. Like I don't know how to get to produce the sweet spot, or how to figure out exactly when to stop. And then it's just frustrating, especially if I'm trying to edit some graphics that it did for me. Oh, disaster. So learning how to do, like, I think prompt engineering is going to go away. I think systems are going to be basically doing their own prompt engineering, but how do you represent good prompts, and how do you evolve those prompts, and then how do you test those prompts, and how do you do your regression test suite for those prompts? I don't know the answers to any of those things, but I think all that stuff.
Yeah, Jim, did you have any thoughts on that or?
I'm just going to agree because
Okay,
otherwise
yeah,
I talk.
no, because
Otherwise we're out of time.
okay, no, it's all about you two. So we'll have to. Well, let's move to the next question then. Christoph asks, LLMs achieve remarkable performance on knowledge-intensive synthesis, thinking about Scholar QA2, largely bypassing the ontology layer. How should today's ontologies navigate expensive formalization and fidelity loss, meeting language models that work so well with messy data? And Christoph, if you want to unmute and elaborate on that, because the question continues as well. If you don't want to elaborate, that's fine too.
Can I
Yeah.
add? Go ahead.
Go ahead,
Go ahead.
Christoph.
Yeah, I mean, I guess I am asking a couple of questions here. Sorry about that. So, Scholar QA is a scientific question answering system, and for me, I think answering scientific questions is a little bit of a holy grail of maybe of reaching capabilities that previously only knowledge representation could provide. And now we've seen LLMs work so well with messy data where no ontology is to be seen. And especially with the drawbacks that ontologies do have, being expensive to create and potentially losing fidelity in your data, which natural language preserves in a way. I'm trying to find where do ontologies still have their place in today's AI landscape. And I've read a couple of you guys' papers on common sense, and I'm really interested in whether we can capture maybe this testicity that it is part of science, or maybe there's even a contradiction here. Trying to kind of bounce back from the bitter lesson that Richard Sutton made me learn a year ago. I don't know if you're familiar with his like 2-page commentary where he says scaling laws do beat structural ingenuity all the time? Thank you.
I wanted to, the first thing I thought of when you said your bitter experience was not Richard Sutton, although that I did read that, but my experience with the DARPA Common Sense project. So I was brought in, my group was brought in to do a common sense knowledge graph to beat, hopefully, the leaderboards in question answering. And Dave Gunning, one of the best program managers, minus the one I'm sitting next to, set up all these benchmarks for years 1 through 4. And the language models were beating year 4 benchmarks in year like 1.5. And so guess what? My knowledge representation was like thrown out the window because it wasn't adding value. And so what we did was we pivoted. And I see Enrique Santos on one of the members here. He took the lead on doing with Alice Mulville and some other people in the group on evaluation metrics. So knowledge representation based metrics for when you should and shouldn't believe it, and where your limitations are. And I think that was a valuable pivot because I don't know about this audience, but I think that the leaderboards are testing things that are easy to test, not necessarily testing the deep understanding. And that's a place that knowledge representation still has a strong place, and ontology-enabled knowledge representation.
Yeah, and let me go to specifically to Scholar QA2. I've been working a lot with astrobiologists lately. Half of what they're trying to do is figure out the right questions. And when you ask those questions of these current systems, you don't get a good answer. Nobody yet has agreed on what the good answers are. So sometimes you can get a summary of some people think this and some people think, but not down at the deep level of mass spectrometer reading, which, it was actually very funny. I was talking to Ed Feigenbaum. I won the Feigenbaum Prize in 2025. We're actually doing stuff with mass spec, which was the very first expert system ever written. It's a lot more sophisticated now. It's a lot harder now. But we still need some of that knowledge because you need chemical knowledge to be able to throw away the bad answers. And that chemical knowledge is not currently being represented in natural language. So when can you use a bond, a double bond, a this, that, the next thing? And we're still grappling with how to say that in the technical terms. But certainly it's the case that a mix of the two is going to be needed if we're ever really going to make progress in these sciences. So as a jump start for, I'm getting into area X, what's some good stuff to look at? It's incredible. For, I'm in area X and I'm doing research in such and such, help, they're not very much help. At least that's been our experience.
Yeah. Cool. Let's go on to the next question. I'm finding the value of and sorry, this is from Faye. Faye asks, I'm finding the value of ontologies in the verticalized space and to force a certain element of determinism in answers by traversing back across. Is that a correct assumption or naive? And where am I being overly optimistic?
That's yours.
Yeah, so in the vertical space, I agree. So often if you're in a vertical space, you're usually going deep. And where you go deep, you need that precision. And so this is a place that it can be incredibly valuable. And actually, in preparation for this event, this AMA, we were chatting about how ontologies are evolving. And I evolve my ontology approach to the portion of the ontology that's going to have heavy reuse. And that doesn't have all those specifics. And the portion of the ontology that is going to get the details and do the integrity checking, and that has a lot of specifics, and it often uses, like many of the properties of the language to be very expressive. So I don't think you're being overly optimistic. I think you have a correct assumption.
Jim, did you want to add? Okay, more thumbs up. Okay. Let's see. And then Paula asks, if I ask an LLM to create queries for data that is described in prose, then the queries always need refinement. If I provide a sufficient ontology with my request, then the LLM gets it right on the first try. OWL is limited in expressivity for this purpose, though annotations do help. Do you see a need for description logic with greater expressivity, even beyond tractability, maybe a new profile in OWL 3?
So my answer is absolutely yes, whether it's in OWL 3, whether it's in some other way. In fact, I gave a talk maybe a decade ago called Wither Owl. And the first slide says, notice I didn't have an H in the word wither. So with an H, it would be where do we want to go? Without an H, it's why is it not helpful? And I mentioned a few things I thought were really needed. One comes up again and again and again and again is procedural attachment, which we know how to do right, have been doing for years, but it's just not in the specs for various reasons. And lots of other things like that. So I've been talking, I've been getting calls from companies now saying, we're starting to use more of the OWL stuff, but it doesn't have this, it doesn't have that. Where do we find this? People are saying, I started with RDF schema, found I needed to add a little OWL, but it doesn't really match any of the subsets. So I think the real change is the original goal of OWL to many people was that we would have reasoners on the web. And therefore, OWL would be the language for the reasoners on the web. And I think what happened by 2012, 2015, data on the web started becoming more important than just reasoning, or as important, or whatever terms we want to use. Now it's a combination of data, reasoning, language, et cetera. So we really need something different. And Larry helps run a signal chat, which often has 200 or 300 messages in a day, and most of them are about exactly this question: what needs to happen? And in fact, part of what Deb and I hope to do at this talk at KGC is actually prompt more discussion by people about exactly that question. Here's what we know how to do. Here's where it's really helpful. But what do we need to go further? And what does that have to look like? And then that can go back, whether it's to standard groups or to business groups or to whatever. But it really is clear that what we have now is a lot of what we need, but not all of what we need.
Yeah, so a good foundation. And so, 100% with what Jim said, we absolutely need more. And we do, the communities, the number of communities know how to do a lot of those things. And actually, OWL had the benefit of decades of research on description logics and the theoretical implications and the computational complexity. But a bunch of these things that we need still have that. But to put it together is a trick, and to put it together in a way that matches the context of what everyone needs is potentially undoable. So what would be great is have this modularization that I can add in these things, or even better, that I can have a tool that tells me what needs to get added in and added in for my use cases where I don't have to do all that work.
But Larry, I'll tell you the way that DAML, which became DAML plus oil, which became OWL, actually came into being when I was at DARPA. I had everybody saying, there's no way we can ever get agreement on what goes into a knowledge language, et cetera, et cetera. So I pulled like 10 or 15 of the top people. I gave everybody an index card and said, what are 10 things that the knowledge representation language must have? Right? And everyone starts writing. And I said, by the way, they're the only 10 things. Everybody starts crossing out. Right. And in the end, we were able to take all 15, all the cards, put them together, and came up with about 17 terms. And I said, okay, unless you guys do better, that's the new language. And of course, then over the next 2 or 3 years, a lot evolved, and logic people got more involved. So there were a lot of differences, but I think it's time to do that again in various forms to get to what Deb said. So what do people really need added? And then how do the people who know how to do this, quote unquote, get better at doing it so that we can be really doing the research a few years out that's going to collide with where the business world is going to have to get to.
And different contexts are going to have different answers.
Yeah.
So I was part of the ICRIS working group, which was the intelligence knowledge representation integration system or something like that. So it was basically a language for the intelligence community, and they wanted a lot of detail, and the language got very expressive, more than common logic. It kind of went into, if anybody looked at Benjamin Grossoff's current call on Clara for DARPA, it's kind of everything. It's non-monotonic reasoning. But it's computational complexity too, but it's probabilistic and it's higher order, and it's like everything.
Nice. Hey, as you're both talking, Jim and I talked a few weeks ago about the Semantic Web paper and how that came about. And ever since then, I've pictured the last 50 years as like 25 years leading up to that, and then the next 25 years. Now I feel like we're at another juncture, the way you're both just talking. Does it feel that way to you? Like, and what do you think, not
So,
25 years, but what do you think the immediate future holds?
Larry, I have a slide I use a lot in my talks these days where I sort of show. I go back in history, and I won't redo that whole thing, but at a certain point, sort of around 2015, 2016, we were actually seeing sort of the mathematical kind of approach, the search engine approach, and the markup approach growing together. It was actually schema.org was the biggest value of it. Google, who had said in early days of DAML, you'll never see markup on even a percentage of our crawl, or now we're by 2016, Peter Norvig gave a talk at the World Wide Web Conference where he said over half our crawl now has machine readable metadata. But then what happened is, the way I describe it is that hit a brick wall at around 2020 when the transformer models came along and just sucked all the air out of everything else. And now what people are realizing again is that all those different approaches that hit that wall were doing good things, and it's time to bring them back together. So I think personally, what I want to see is a lot more heterogeneity, a lot more composability. Hey, this works for me here, this works for me here. And the place where Deb and I always start in any real project, no matter who we're working with, is use cases. What do you need this thing to do? And then build out from there.
Yeah, and within the use case, it's not just what do you need it to do, but give me some example questions, typically called competency questions. And don't stop there. Give me the answers, some example answers, and don't stop there. Keep going for how you got that answer. And don't stop there. Tell me what was hard about getting that answer. Now we're getting to the place that we figure out what kind of representational power we need, what kind of reasoning we need. And now we actually are in a place where we can start to scope.
Nice.
And, again, I tend to come back things almost from the other direction, which is, okay, you take your simple knowledge that you've got, you get up to something like Wikidata, and all of a sudden you've got, this knowledge graph with literally millions and millions of things in it. How do you decide which ones are relevant? How do you decide which ones to bring in? Well, I start doing the same exact process Deb just said, starting, quote, from the bottom, unquote. So these things are converging. And again, that's really what our talk wants to get people thinking about, because we're not going to present answers. We're going to present, this is the hard new question. How are we going to do this stuff right?
Yeah, and people ask me what methodology I use for building ontologies. They say, do you use top down? Well, kind of. Do you use bottom up? Well, kind of. Do you use, and then what do you really do? I'm like, well, middle out is more like what I really do, but I do all of those things.
And I've used that phrase middle out. I used to use the example when my wife and I would go driving in Europe prior to the GPS days. She would have the map on her lap and I would be driving. And she would say, like, turn left here. I was like, I can't. She's like, why? I said, there's no street. She's like, yes, there is. Look, the map says there's a street. We would fight between, quote, the knowledge rep and the reality. And I kind of came up with that term. Well, I mean, I came up with that term middle out to say, okay, clearly we can't be exactly where you think we are on the map, or something has changed, but I couldn't possibly get us there just using what I can observe in the world. So we have to evolve methodologies that, quote, go both directions.
Got it.
And that's always been my philosophy of research, is start in whenever you can find a community where where two groups are arguing about opposite things, look at the middle.
Yeah, and look at where they agree. So I do all these knowledge acquisition, or I used to do all these knowledge acquisition meetings, and I always would get a couple of experts, not 8, because that's too many to handle. Not one where one is more, or not one, not 2 where one is like way more senior than another one. Like you need at least 2 somewhat equal-ish people who are willing to speak up and preferably disagree. And then figure out where you can get consensus. I heard you say X, and like blood is a tissue. Oh God, no, it's not. Oh God, it has to be. You will never get agreement in medical communities on that. So figure out where you can get some agreement.
I have a friend in the UX world who says this thing in meetings. When they talk about friction in interaction design, they'll say, without friction, there is no traction. And I think that's exactly what
Right.
you were just
Right.
describing. Yeah.
Yeah.
Hey, I want to put out an invitation. I
Yeah.
think we've got through all the questions in the chat, but if there's anybody online who doesn't like writing and would like to raise their hand and ask a question orally, that's fine too. But I also wanted to, one thing while we wait for that, Jim, I did want to make sure we get in a little bit of reflection on the 25th anniversary of the paper. Like, do you see the emerging agent architecture doing what you envisioned or what the Scientific American editor envisioned in the opening anecdote, or do you have any reflections on that? Or
So we won't have the next hour or two, but I will mention that Ara Lasala and I are giving a keynote at the KGC conference, pretty much on exactly that topic. But so we really feel that the current agentic AI, part of it is rediscovering stuff we knew and advocated a long time ago, but part of it is new and different. And if we say it's just the old stuff, we're wrong. And if we say it's just the new stuff, it's wrong. So we really want to see that conversation come together. And we're seeing it. I mean, the fact that we're having this AMA, the fact that our paper got accepted, the fact that, you know, groups like Ontology and Dataworthy and things like that are forming because the real world applications are driving us towards realizing that this stuff has to come together. And if my agentic AI is, oh, it'll order something for me in Amazon, big deal. But it's when it starts getting interoperability, starts getting tying recommendations that are customized, not personalized. If anyone saw the Anthropic ad at the Super Bowl, I think
I like
was
that one.
absolutely gorgeous. And if you haven't seen it, just go
yeah,
search for it
yeah.
because we're not going to talk about it in detail. But again, it's if AI systems start to build advertising in, all this stuff goes to heck unless you're able to start saying, okay, so what's trustworthy, what's not, where's it coming from? And that brings us back to a lot of the same questions we had at the beginning. So what I'd say is we were a little bit naive on just how much information would be out there. Even Tim, who made Aura and I feel like pikers because we were only talking about tens of millions of things out there. And Tim was like, no, bigger than that. But all of us now see, trillion weights and, read billions of web pages. And, it's a new world, but a lot of the same questions are still there. Ambiguity is still ambiguity. People are still people. Computers still don't, quote, think like we do. World modeling is the big buzzword nowadays. Well, what is world modeling going to be? It's going to be figuring out how to scale up some of this representational stuff through a different kind of learning because we know it's not going to learn through, the same mechanism that the language learning systems are. So again, I see places where communities can come together. I see place where communities go apart. But I think that paper, interestingly, is being rediscovered now in exactly the way you said, Larry. It really came together in 2012, 2013 with data integration, right? Then kind of grew out again because people were saying, hey, now that we have a lot of data, what can we do with it? Then data and language came together, and now it's okay, so now how do we control that? And that's where we live together in that middle. And that's a lot of what Aura and Tim and I were thinking. And we have a slide, it'll be in the keynote of what the original outline for the article looked like. But let's just say there was a piece in the middle that just says, and then a miracle happens. And
I was going to ask if it said vague but intriguing. But
no, that was on Tim's
I know
original
that was
paper. This was a later
yeah. Hey, one thing is, well, actually, Deb, did you want to add to that? I saw you kind of leaning forward a minute ago.
Oh, yeah. So I think humans and computers using computer agents is here. It's here in kind of a scary way. So I just came back from TED, Technology, Entertainment, and Design, and the OpenClaw guy gave a talk. And it was really interesting to hear the reaction. A lot of people were terrified by him, like truly terrified. But he's talking about the potential But how do you know when you can safely use that potential? How do I harness it in ways that I can do like little things that don't have big bad potential results? Like, I want to get a present for some acquaintance in a timely manner, and like if it makes a little bit of a mistake, no big deal. But if I'm looking at a life and death medical situation, man, it's got to be perfect. And I want to know how it's been checked a whole lot of times. And I want to make sure that I'm not sharing private medical information. So there's all sorts of controls and checks that have yet to be appropriately handled.
And all I would say, Larry, is, I encourage everybody who's t talking the word agentic to drop that IC and then do a search, because you'll find papers. And actually, it was very funny because the other day I asked one of the LLMs what was the first paper to talk about agents on the web, and it said, well, there's some going back, but the really first one was the Scientific American article,
That's good.
which made me feel great because it
Really?
didn't know who I was. It wasn't
Well,
personal.
didn't Aura do something that he thought of as agentic AI even before that?
Oh, I mean, I was doing things.
Oh,
We had a whole agent and AI community back in the mid 80s.
wow.
Um, Belief, desire, intent. A lot of the robotics work grew out of that. Leslie Cabling. I mean, I could just name after name after name of famous AI researchers. Well, the Martha Pollack, who eventually went on to become the president of Cornell, was one of the leading people in that.
Cornell,
We had
Michigan.
No, she was
Cornell.
president of Cornell.
Oh,
Yeah,
okay.
she went from Michigan.
Oh, she went from
So
Michigan.
anyway,
Okay,
she was
sorry.
provost at Michigan.
Oh, got it.
President.
Sorry.
One thing, we're
Anyway,
almost at
so
time,
so
but
on and on. I mean,
yeah.
it's sort of, I really think that there were a lot of good ideas. There were a lot of stuff we understood, and revisiting the modern world with some of that older vocabulary. We talked about beliefs. We talked about desires. We talked about intentions, right? You can't lie. You can't talk about whether something is lying or not without saying something about intention. And when people say, well, these AI systems are starting to tell lies or do this or do that, well, what was the intention? Well, it either came from human feedback or it came from some kind of do your best to fit some function. And it's not sort of the way we do intention. And, it a lot of this stuff needs to get revisited.
Yeah, one thing, as you're both talking the last 5 minutes, I'm like, there is so much this community has to offer to the current AI situation, and there's so much, integration and effort on our side. It feels like most of it's coming from the knowledge representation side. How do you think we might inspire a little more curiosity from the machine learning folks about how knowledge representation might be able to help their architectures?
The best technique I have is with examples. And so, quick and dirty example, well, not necessarily dirty, but quick examples in a domain that they can relate to, where they can see the benefit and where you can contrast it to, your favorite LLM usage or your favorite things that people would think of first to compare it to. So show the benefit. And then if you're trying to get funding, show a potential financial impact for your potential funder.
Nice. Jim, did you have
And again, I do feel, Larry, remember, 25 years ago, we wrote this article that we're now talking about, right? We need people who are looking 5, 10, 15 years in the future. 25, we were just lucky, let me put it that way. We had one of the all-time geniuses in my life, Tim, helping us. So that really made a difference, partly because it gave us visibility, but partly because he really is brilliant in ways that are hard to describe. But I think that vision has to not be what are we going to do in the next 2 years? It's where do we want to go? And I don't think where we want to go is so-called AGI using current models, right? I'm not looking to be replaced. I'm looking to be helped.
Yeah, augmentation instead of
augmentation? Yeah.
yeah.
And I think a lot about Jan LeCun. Like we think about the machine learning, and he said, nah, this isn't going to do it. But he didn't come to our camp. Went to Paris and got $1 billion to do some new thing. So,
Well, but if you look at the world modeling stuff, they're not really doing knowledge rep in the same terms we're using, but they are trying to learn something like knowledge rep,
Mm.
right? In different forms. And, we were playing with this, again, all these things 30 years ago, people tried various aspects of it. We didn't have enough data. We didn't have enough machine power, et cetera. We're where we are now. I think Jan is starting to look out at something that's going to be another 10 or 15 years and require another order of magnitude of power, a lot more information coming in, a lot of rethinking how that information comes in. Because even if I'm feeding you a lot of world information, how do I've had 69 years of learning about the world, right? You're going to compress that into one little video that you can show a computer. It's going to be hard unless you can start figuring out what are the important things you're trying to do. And once you're into that conversation of what's important, what's critical, what's the goal, those are all the words Deb's been using.
Right. So context is kind of everything.
Yeah.
How do you represent it? How do you use it? How do you teach it to the LLMs? How do you teach it to those integrated systems? How do you communicate it to somebody who's trying to figure out whether they should use it or whether they should count on it for a super important time-sensitive question? There's plenty of PhD theses in that. There's plenty of research left to do in that.
Yeah. Hey, I see Min is about to give us the hook, so we should probably wrap it up. But hey, I want to say, is there anything really quick that either of you want to, or either or both of you want to mention before we close, just to let you get the last word in?
So, we've been working together forever and have been on many, many joint projects and, but really, sort of this paper grew out of us realizing that we were together in a new place now and that we needed to start trying to put words around it. And so we said, let's see if we can just come up with a short little description. That became the abstract. Now we're building it out into the talk, and hopefully that's going to lead to being able to get a community excited about really this stuff coming together.
Right. And come to KGC if you possibly can. And definitely join the groups if you can't make it there physically, at least join virtually in the Slacks, etc.
Nice.